A huge asteroid, several hundred feet across, is dashing towards Earth through the black nothingness of the cosmos. Ooh. Brace for the terrible news. There's a 72% chance it might hit Earth in 14 years, with potential impact zones being North America, Southern Europe, and North Africa, some of the most densely populated areas on the planet. Astronomers have been keeping a close eye on the space invader for a few months, but now it's moved too close to the Sun, and tracking it is impossible for the next 7 months. Of course, there's a 28% chance that it will miss our planet altogether. But what if it doesn't? Global devastation and destruction, that's what. Thousands of lives lost, billions and billions of dollars in damage, entire species wiped off the face of the Earth, ruined cities and towns, destroyed fields and forests. We're left wondering whether it's the future awaiting for us. Well, now you can breathe easy. That's just a hypothetical scenario created by NASA to prepare for a situation like this. The space agency has been thinking about this kind of disaster for years. Even cooler, they run what-if asteroid exercises every 2 years to get scientists, state agencies, and international experts on the same page. The last one occurred in April. Over 100 people took part in that event. During such asteroid drills, experts pretend that a giant space rock is heading our way. Then they work through all the tricky questions they can come up with, like how big is it? Where might it hit? What should we do? It's like a massive brainstorming session to make sure that if it ever happens, we won't have to start from scratch. To make these scenarios feel as real as possible, NASA's Center for Near-Earth Object Studies gets involved. These are folks who track real asteroids and calculate their orbits. So they simulate months of asteroid observations, complete with uncertainties about its size, trajectory, and potential impact zones. It's the kind of uncertainty that makes decision-making way harder, just like it would be in real life. Now, if an astronaut really was aiming at Earth, it wouldn't be just one country's problem. It would be everyone's. That's why this exercise brings in international experts. In April, it happened for the first time. They worked alongside U.S. agencies like NASA's Planetary Defense Coordination Office and FEMA to understand how the world might respond to such a crisis, since an asteroid impact would have dire consequences globally. Now, the big question is, can we actually stop an asteroid from hitting Earth? Here, there are two main options experts consider. First, we could send a spacecraft to gather more info. If we knew more about the asteroid's size, mass, and orbit, we'd be able to make better decisions about what to do next. The second option is to try to deflect it. Basically, it means bumping the asteroid off its course so that it misses Earth. This might sound impossible, but NASA's DART mission has already proven that we can do it. 2 years ago, they crashed a spacecraft into a small asteroid called Dimorphos and successfully changed its orbit. It was a huge victory for planetary defense. But missions like that take tons of time to plan, prepare, and carry out. That's why spotting dangerous asteroids as early as possible is so important. Currently, NASA is working on a new telescope called NEO Surveyor, which is set to launch in 2027. Unlike good old telescopes, NEO Surveyor is designed to detect even the trickiest asteroids, including ones orbiting close to the Sun. It'll give us a better chance to act early and potentially stop an asteroid before it becomes a threat. If you still think that an asteroid impact is something out of science fiction and the threat isn't real, how about this? Early on Sunday, January 21st, a small asteroid about 3 feet wide entered Earth's atmosphere and luckily burned up over Germany. NASA's Scout Impact System spotted it 95 minutes before it hit and predicted exactly when and where it would arrive. At 1:32 a.m. local time, the asteroid turned into a blazing bright fireball, visible as far away as the Czech Republic. Some small meteorites might have landed near the impact site, about 37 miles west of Berlin. This is just the 8th time ever that an asteroid has been detected before it hit Earth. It's a splendid example of how tools like Scout are helping us track asteroids and prepare for anything bigger that might come our way. Here's another example. A small asteroid turned the skies over northeastern Siberia into a breathtaking light show on December the 4th, burning up harmlessly in Earth's atmosphere. The space rock, about 28 inches across, was spotted just hours before it hit. Thanks to observations from astronomers around the world, a special alert system managed to predict the impact to plus or minus 10 seconds. The asteroid entered Earth's atmosphere at 1:15 a.m. local time. The authorities were put on alert, but there was no damage reports. NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS, spotted the rock 12 hours before it entered the atmosphere. This makes it the fourth imminent impactor, which is an asteroid discovered within hours of its expected impact, detected this year, and the 11th overall. Now, China also has big plans for planetary defense. They're working on their first mission to hit an asteroid, and it's got a double purpose. One spacecraft will crash into the asteroid, and the other will hang back to study the whole thing for up to a year. In other words, it's not just about protecting Earth, it's also a way to learn more about the solar system. The target is an asteroid called 2015 XF261, which is a mouthful, and also about 100 feet wide. It flew by Earth recently on July 9, passing us at 31 million miles. True, it's pretty far away, but the space traveler was zooming by at a speed of 26,000 miles per hour, 30 times faster than the speed of sound. China is going to send a space probe to study the asteroid. They're hoping to learn more about its structure and composition, which could help us with future planetary defense missions. Then they plan to hit the asteroid with another spacecraft to test the impact, and the first space probe will stay there to observe the remains for up to a year. Timing is critical for this mission, and the asteroid offers some good opportunities in the next few years. Thus, in March and May of 2027, the asteroid will pass within 20 million miles of Earth. In April 2028, it'll get even closer. By that I mean 13 million miles away. A year later, in April 2029, the asteroid will end up just 4.2 million miles away, making it the best shot for a mission. Another decent chance will be April 2030. That's when the asteroid will pass our planet at 4.4 million miles. To give you some context, NASA's DART mission once targeted an asteroid 7 million miles away, and the trip took 10 months. So China's planners have to pick the right moment, depending on how long their spacecraft will need to get there. The mission is expected to start around 2027. At the same time, this won't be China's first attempt to target an asteroid. Back in 2023, they were planning a planetary defense test with a different asteroid, which is also about 100 feet wide. It's not clear why they switched to the current one, probably because the timing works better. Most asteroids are basically time capsules from 4.6 billion years ago, leftovers from when the solar system was just forming. Studying them could tell us a lot about how planets, including Earth, came to be. So, China's taking on something that combines planetary defense and pure space science. They're definitely making big moves in the space exploration game. If an asteroid like Apophis hits Earth, we will be destroyed. Massive earthquakes will strike, and tsunamis will flood everything. Apophis is a billion-year-old celestial body that has been in the solar system since its inception. So you might be thinking, well, how likely is it that this giant space stone will collide with our planet in 2029? Well, let's find out, shall we? Apophis is a big, bad asteroid discovered in 2004 by the Kitt Peak National Observatory in Arizona. Since then, it has proudly held the title of one of the most dangerous asteroids ever located. It's around 1,100 feet wide, which is a bit bigger than the Empire State Building and the Eiffel Tower. Because of how scary it was named Apophis, like the Egyptian immortal creature that was considered to bring eternal darkness and destruction to Earth. Oh boy. In 2021, researchers had a once-in-a-lifetime opportunity to study this floating rock when it passed near our planet, and we'll come back to that in a minute. Now, some scientists say that there is a small chance of Apophis hitting the Earth on Friday, April 13, 2029. The Yarkovsky effect is to blame for this, since it can slightly nudge this space rock towards Earth. This effect originates from the uneven emission of thermal photons from a rotating celestial object, resulting in a fascinating force exerted upon it in space. These emitted photons possess momentum and play a pivotal role in shaping the dynamics of the body. The asteroid has two sides, light and dark, just like the Moon. The light side faces the sun and is warmer than the dark side. But the thing also turns, so the sides constantly change direction and temperature. This change could be detrimental because it slightly pushes Apophis toward Earth. Unfortunately, nobody knows how the Yakovsky effect will influence the asteroid's path. On the other hand, on the asteroid's last flyby of Earth in 2021, astronomers used radar to take accurate measurements of its trajectory and confidently concluded Apophis will safely miss Earth in 2029 by about 20,000 miles and won't bother us again for at least 100 years. Now, generally speaking, every 8,000 years, our planet is hit by a falling star that has similar dimensions to those of Apophis. The last time we were hit by a slightly smaller meteor was in 2013. A new spacecraft developed by NASA called the OSIRIS-REx was launched in 2016 to collect samples from another slightly less terrifying celestial body called Bennu. 4 years later, it finally arrived at the thing, got some samples, quickly said goodbye to Bennu, and started traveling back towards Earth. The samples were safely stored in a capsule dropped in Utah. So far, this has been the most significant sample ever taken from an asteroid. After the delivery, the spacecraft didn't waste any time and started chasing Apophis. Now, OSIRIS-REx has been renamed to OSIRIS-APEX and is currently playing tag with Apophis. With some luck, on the 2nd of April 2029, when the asteroid zips close by Earth, the spacecraft will reach Apophis and land on it. It will stay on Apophis for 18 months, collecting valuable information and taking thousands of pictures. The asteroid will be monitored with the help of powerful telescopes. At some point, Apophis will get too close to the Sun, and then all the monitoring work will be on Osiris's apex back. If you live in Europe, West Asia, or Africa, you're one of those lucky people who will have a once-in-a-lifetime opportunity to see Apophis with the unaided eye. It'll be visible in the sky in these regions in 2029, and those who have telescopes will be able to spot it once again in 2036. OSIRIS-APEX will experience some problems because the asteroid has a thick crust, and the spacecraft won't be able to collect data as easily as it did with Bennu. OSIRIS-APEX has a unique thruster that will blow all the dust from Apophis while landing. This will be a perfect chance to analyze the surface of the asteroid to see what it's made of. The craft will spend 1.5 years mapping the asteroid, trying to detect changes in its shape. All this research will show how the celestial body is likely to move so we can better design plans to protect Earth from such things. In 2025, NASA is also going to launch the mission Apophis Pathfinder, and it will be the first spaceship to ever touch this asteroid. It will land approximately a year after its launch. Also, NASA has proposed sending a swarm of tiny craft into space to help humanity develop effective protective tactics against asteroid strikes. We know that Apophis originated in the primary asteroid belt between Mars and Jupiter. In the past million years, this celestial body has changed its path because of the considerable influence of Jupiter's gravitation. Now it seems like it favors the Sun more, meaning this asteroid will come very close to Earth. That's why it's classified as a near-Earth celestial body. A lot of tests and research have been done to find a way to deal with asteroids. Some solutions include drilling and detonating the space body from inside, or testing new technologies, like attaching rockets to it and trying to steer it away from Earth. We can also hit it with something moving at high speeds to make it change its course. Apophis is an S-type asteroid made of rocks and minerals like iron and nickel, and is shaped like a peanut. It can tell us a lot about the past and possibly the future. Sampling this space object could reveal how life on Earth began and how plants appeared. There are many theories that suggest that water arrived on our planet on an asteroid or a comet. Asteroids are like priceless time capsules. Unlike rocks on Earth, which have undergone thousands of changes, like erosion, most celestial bodies are still intact and much easier to study. When meteors fall on Earth, they get covered in debris that's impossible to clean. That's why studying Apophis while it's still in space is so important. Also, some asteroids are made of precious metals like platinum. Right now, we have a high demand for metals that we use in production, and mining metals on Earth is quite tricky. Just one large meteor might have iron, nickel, gold, and platinum that could last us millions of years. If Apophis has this amount of metals, well, we'd want to break it down and bring it back to Earth. One space rock could be worth quadrillions of dollars, making space mining highly profitable. And still, it would cost us more to get it back to Earth than to dig up these materials here. As technology progresses and new kinds of rockets are developed, this might become possible at some point. So, even though we're safe for the next 100 years from Apophis, you probably still want to see what would happen if something like it did impact. Come on, sure you do. Well, first let me tell you, you'll hear the sound of the collision and know what's happened even if you're miles away. You should leave your house or apartment immediately. Shortly after the impact, massive earthquakes will strike, and many tall buildings will fall. So, staying away from cities might be your best option if you have a choice. But don't escape by car. There will be massive traffic jams, and everyone will panic. Going on foot or by bike is your best option in this scenario. A prime way of transportation will be traveling by plane, so if you've always wanted to get that pilot license, now you've got a good excuse. If you have time, take along extra snacks and water, and an extra pair of socks. It's nice to live by the ocean or the sea, but in this scenario, it's the worst place to be, because giant tsunami waves will hit coastlines after the impact. If you live far away from the impact area, the tsunami might take 30 hours to arrive. You'll have a bit of time to prepare.
Asteroids aren't as rare on our planet as we may think. About 17,000 of them visit us every year. You've probably seen at least one in your life. For example, if you've seen a shooting star. They leave these bright tails behind them as they pass through Earth's atmosphere. Of course, they only look beautiful in the sky. If they reach the ground, the consequences would be catastrophic. Luckily for us, most of them explode 30 to 50 miles above the surface. Their mass is too small for them to withstand such a journey to the end, so most of them remain harmless to us. But we shouldn't underestimate them. Let's start with the smallest ones. 1 to 3 foot high asteroids are about the size of a person. They're too small to cause any real damage. Most often they explode in the atmosphere, without even reaching its lower layers. But at the same time, they splash up tons of energy over the surface every time. 13 to 15 foot asteroids, the height of giraffes and mammoths. These larger meteorites come to us less often, once a year and a half. Like the previous ones, they, fortunately, don't pose a serious threat, but they splash out much more energy. 30 feet, the height of a 3 to 4 story building. They visit us once every 10 years, and now we're talking seriously. It throws out a wave that could demolish an entire city. I think you understand how catastrophic the consequences would be if this asteroid touched Earth. 65 feet, multi-story building. They like to visit Earth once every 60 to 70 years. Good news, it explodes at 12 miles above the ground. Its released energy could destroy an entire region if it touched the ground. Bad news, such an asteroid has already visited us recently, and the consequences were pretty rough. It all happened in a city called Chelyabinsk. On February 15, 2013, at about 9:20 a.m. local time, the giant slowed down in the Earth's atmosphere and then broke up into small pieces at 14.5 miles above the Earth. These pieces then flew in different directions. It shattered the windows all over the city and damaged many buildings, including people's houses, schools, and others. It took a while to repair everything, and the scale of this destruction was quite serious. As a result, there were 1,615 injured. But fortunately, no casualties. At least we're safe for the time being. The next such asteroid may come to us only in the 2070s or 80s, and no one knows where exactly it wants to land. Now let's move on. 300 feet. This is the height of the Statue of Liberty together with the pedestal. Such a giant can be seen every 4,500 years. and this is the first asteroid on our list that may literally crash into Earth. The consequences are disastrous. Not only may it demolish an entire city, but it can also set fire to neighboring areas. Well, some people even witnessed such a meteorite land on our planet. The notorious Tunguska meteorite is the biggest asteroid disaster that people have ever seen. It all happened on June 30th, 1908 in eastern Siberia. The meteorite was bright, like a second sun, and people felt the heat wave when it just approached the Earth. It exploded near the river. Fortunately, the whole area was surrounded by taiga, and there were no big cities nearby. But even there, it immediately destroyed a lot of trees. Serious forest fires broke out. The sound of the explosion was heard by people hundreds of miles around. At tens of miles around, all the houses' windows broke. The magnetic storm that resulted from this collision lasted 5 hours. The consequences were truly disastrous, but perhaps this is not the worst thing that awaits humankind. 99942 Apophis, 1,215 feet. It's slightly bigger than the Eiffel Tower. This meteorite, as scientists discovered in 2013, will be our next guest. Collisions of such force occur in about 100,000 years, and this one is gradually approaching. The force of such an explosion is equal to the force of the catastrophic eruption of the Krakatoa volcano in 1883. This eruption is considered one of the most destructive in history. It caused a terrible tsunami. 165 cities and settlements were completely destroyed, and another 132 were seriously damaged. People all around the globe could feel the consequences of this eruption, at least to some degree. Such an asteroid could leave a 3.5-mile crater, and this is one we'll face in the distant future. But calm down, no need to panic yet. By 2070, the meteorite will be almost 174 million miles away from us. It still has a very long journey ahead of it, so we're safe for at least 100 years, or even more. Besides, our planet has survived something even worse. 3,280 feet. This is higher than the tallest tower in the world, the Dubai Burj Khalifa Tower. Such collisions occur once every 500,000 years. We're not sure when such a collision occurred the last time. 70% of our planet is covered with water. If such meteorites fell into the ocean, it would be extremely difficult to find their traces. But we can assume the possible consequences. The wave would have swept across the entire hemisphere. The crater would be about 9 miles in diameter, and that would be a complete disaster. The last event of such a force happened 26 to 28 million years ago. It was an eruption of the supervolcano La Garita, which is located in the southwest of Colorado, USA. It was one of the most powerful known supervolcanic phenomena in history. During this monstrous eruption, a significant part of the current state of Colorado was destroyed. Scientists are still not sure how far the ashes have spread, but there was an even bigger meteorite in the history of mankind. The consequences of that impact were irreversible for an entire species of animals. I think you know what I'm talking about. Chicxulub meteorite, the thing that wiped the dinosaurs off the face of the Earth. This happened about 66 million years ago. These collisions in general happen about every 500 million years. The height of the Chicxulub meteorite was 12.4 miles. It's so high that when it touched the ground, it could reach the stratosphere. Even looking at the 124-mile diameter crater left by this meteorite, you can understand how huge it was. When it collided with the Earth, millions of tons of energy were released. This is an unimaginable disaster. It fell at a very steep angle, creating a giant cloud of dust and chemicals that spread around the world. This dust had a very thin layer, but also a mass of 50 trillion tons. The shockwave swept across the entire planet. It caused several earthquakes. Volcanoes began to erupt actively. Forest fires broke out everywhere, all over the world. The amount of soot and carbon dioxide released into the atmosphere is invaluable. The Earth was closed from the sun for several days. Darkness reigned all over the planet. Planets couldn't produce enough oxygen, so there was nothing to breathe. The temperature on the continents and in the oceans dropped by an average of 50 to 90 degrees Fahrenheit. Sounds horrific, doesn't it? And, of course, it caused one of the greatest extinctions in the history of the Earth's biosphere. Amazingly, the Earth was able to recover after such a catastrophe. This event became the boundary between the Mesozoic and the Cenozoic eras. So now, those who wondered, how could a small meteorite destroy all the dinosaurs, probably understand the answer. Perhaps the largest collision in the history of our entire planet was not a collision with a meteorite, but with an entire planet. This happened many, many billions of years ago. Theia, as this hypothetical dwarf planet was called, crashed into our Earth, releasing an incommensurable amount of energy, just quadrillions of fuel. The Earth then instantly turned into a giant fire, and it was this collision that led to the creation of the Moon. All that sounds terrifying, I know, so let's just hope that you and I will never see anything like this.
You look up and see a bright orange flash in the sky. A bit later, you hear a boom so loud the window panes around you burst into pieces. And then you see it. A giant piece of space rock burning high above your head, heading for Earth. When it touches the surface, the explosion leaves behind an enormous crater. It's 12 miles deep and as wide as Lake Michigan. After that, 3/4 of all living organisms on our planet are on the edge of survival. This event took place about 66 million years ago, and the bright flash in the sky was the very asteroid that wiped out the dinosaurs. These days, people have many ways to protect themselves, like we could hide in bunkers deep underground and survive. Such bunkers would already come in handy, since there are many asteroids in the sky, and some of them are just waiting for their ticket to Earth to wreak some havoc. For example, the asteroid 1990 MU. In 2027, it'll come alarmingly close to our planet. Many people fear that Earth's gravitational pull will trap the rock, which is the size of 2 Brooklyn bridges. In this case, it'll start to move closer and eventually crash into the planet's surface. Such an impact would cause a shock wave that would be felt on other continents. Once the asteroid hit the ground, there would be an explosion. It'd be so bright, people would think a new sun appeared right here on Earth. The collision would release a huge amount of energy that would then turn into heat. Everything around the impact site would catch fire. And if the asteroid fell in the water, it would cause tsunami waves higher than the Empire State Building. Many coastal cities would be flooded. The dust that would rise after the explosion would cover the sun. The world would be plunged into darkness. If the dust stayed in the air long enough, the climate on the planet would change and Earth would start to freeze. If you think such a small meteorite can't cause serious damage, look at the Chelyabinsk meteor. It hit the Earth in the winter of 2013. When the space rock entered the atmosphere, people miles away heard a loud bang. The brightly burning object was approaching the surface at about 11 miles per second. Halfway through the flight, it split into several pieces. This caused several stronger shock waves. When the meteorites hit the ground, it caused a major earthquake, and the aftershock from the explosions shattered the windows of 5,000 buildings. People in 6 cities around the crash site felt the aftereffects of the fall, and this meteorite was only 60 feet wide. Fortunately, the asteroid 1990 MU will move past our planet. We'll be safe. Whew! But the next asteroid to approach Earth is going to be 3 miles wide. It's called 3122 Florence. If this giant hit our planet, it could wipe entire continents off the face of the Earth. In 2017, this space rock got awfully close to us. It could be seen in the sky even with a small telescope. Now, the next asteroid is the biggest one to worry about, 1999 JM8. It's about as wide as Manhattan, and it has an unnerving habit of approaching Earth a bit too close for everyone's liking. A small asteroid named 2020 VT4 got closer to our planet than all others have ever done. In November 2020, it flew over the Pacific Ocean at an altitude a bit smaller than the distance from Los Angeles to Las Vegas. That space rock was about the size of a big car. If it did make it to Earth's atmosphere, it would burn up completely before touching the ground. Falling asteroids and meteorites aren't uncommon on our planet. Luckily, most of them burst into flames and burn up before they enter the atmosphere. Mars is to blame for such frequent meteor showers. The planet isn't far from the main asteroid belt in the solar system. Sometimes, the gravitational pull of the red planet grabs asteroids from there. Then, Mars spins them around and flings them in our direction, just like a slingshot. So, Mars is a bully. Good thing we're protected by Jupiter. It's the largest planet in our solar system, and it has an incredibly strong gravitational field. It keeps the asteroid belt in line and protects us from being constantly hit by a rain of meteorites. And that's good news, considering Ceres is in the asteroid belt. This enormous space rock is so big that it was once considered to be a planet. Then, for many years, scientists called Ceres an asteroid. But in 2006, it was finally classified as a dwarf planet. This space object contains a third of the total mass of the asteroid belt, which is about 4% of the Moon's mass. If Earth were as large as a nickel, Ceres would be about the size of a poppy seed. So, what if an asteroid several miles across was heading toward our planet and people had to stop it? Well, we could break the space rock into smaller pieces. A massive explosion could be used to do this. People wouldn't even need to land on the giant asteroid. Getting close to its surface would be enough. Boom! A powerful burst of energy would split the asteroid into several large pieces and tons of debris. The smallest rocks would burn in the heat released in the blast, and it would also change the asteroid's trajectory. The larger fragments would burn up while entering the atmosphere. All witnesses of this unusual meteor shower would have a chance to admire a beautiful fire show. Another means of protection could be a kinetic battering ram. Simply put, it would be a huge object that people would send towards the asteroid approaching Earth. Or it could be a heavy spaceship. This is the method scientists produced to prevent the asteroid Apophis from falling to Earth. This guy is 1,200 feet across and often passes by our planet, coming as close as 19,000 miles above Earth's surface. The asteroid is going to pass close to our planet again in 2029, and there is a possibility that in 3036 it might crash into the Earth. If it happened, the explosion would leave a crater more than 3 miles across. Within 6 miles of the impact zone, all buildings and subway tunnels would be crushed or severely damaged. The event would also trigger a powerful earthquake. In the area of 30 miles away from the crater, car windows and window panes in houses would be shattered. And 75 miles away from the impact site, the earthquake would move furniture and buildings. One way to stop such a catastrophe is to build a heavy spaceship. It would take off from Earth, speed up, and then ram into the asteroid with great force. This impact would alter the course of the huge space rock, and it would fly past our planet. We could also try to stop the asteroid by wrapping it in foil. This would make its surface reflective, and then solar pressure might gradually change the asteroid's trajectory. Another alternative is using the gravitational tug. In this case, we would send an unmanned spaceship, large and heavy, toward the asteroid. It would fly over the space rock and slowly draw the thing closer with its gravitational pull. A small change, of course, would be enough to make the asteroid fly past our planet. Another way to protect Earth would be to build a system of giant lenses in space. Perhaps you've tried focusing sunlight with eyeglass lenses. Then you know how hot this sunlight can get. Now imagine having many giant lenses that are all directed at one point. Scientists think that focusing such a powerful beam of light on the asteroid would make the rock melt and evaporate, slowly changing its route. And one more way to protect ourselves from the asteroid would be to install several rocket engines on its surface. It would turn the space object into a rocket, and we could set its course from Earth. Rogue stars pose a much bigger danger. Like asteroids, they fly through space and can collide with anything in their path. The problem is that they have a gigantic mass, sometimes comparable to our Sun's. Around 70,000 years ago, a duo of rogue stars whooshed past the Sun. It didn't affect Earth, but caused some disturbance on the outskirts of the solar system. This event is likely to happen again someday. The rogue star Gliese 710, about half the mass of our Sun, is moving toward our solar system right now. There's a possibility that it'll begin to grab asteroids from the outer asteroid belt and toss them at us. And then, rare meteor showers you can observe these days will become a regular occurrence. But right now, this rogue star is extremely far from our world, and there's a bigger chance that it'll pass by without affecting our peaceful existence.
We're flying past the planets of our solar system. We pass by Mars, Jupiter, Saturn, Uranus, and Neptune. Then we move through dark space beyond the edge of our world. We've reached our destination. It's the Oort cloud. It's a hypothetical region around the solar system that holds tons of asteroids and blocks of ice. It's likely to be where the largest comet in human history was born. And now, it's heading toward the sun. Bernardinelli Bernstein was discovered totally by accident during the Dark Energy Survey. Our telescopes were pointed at distant space. Their main goal was to learn more about how the universe was expanding. Astronomers also wanted to make a more detailed map of the observable universe. Scientists analyzed over 80,000 images and found a moving object. It was alarmingly close to our home planet. Its size was an impressive 62 miles. That's about the width of Lake Michigan. It was an already active comet with a long tail. Usually, comets get a tail when they come close to the sun. The heat from the star warms the comet's surface, and light materials, like ice, begin to evaporate. This forms a cloud of steam and dust that stretches far beyond the comet. But Bernardinelli Bernstein is too far away from the sun to start heating up. This means that its surface has a different composition. It might be solid carbon monoxide. This increases the luminosity of the comet. That's why it can be observed with telescopes on Earth. We can compare Bernardinelli Bernstein to the largest meteorite to ever fall on Earth. About 66 million years ago, our planet was hit by a meteorite about 6 miles wide. At that time, the blast wave from the collision went around Earth several times. Tsunami waves caused by the impact were taller than the largest skyscrapers, and the energy from the explosion set huge areas on fire. Almost all living creatures, including dinosaurs and ancient fish, ceased to exist. The meteorite left a crater 3 times the size of Manhattan. The place where it fell was rich in sulfur. This substance evaporated because of the abnormal heat and gathered into massive clouds. This caused acid rains that were falling on Earth for several more weeks. Our newly discovered comet is 10 times bigger. If it were flying toward Earth, you'd see it with the unaided eye long before the impact. It looked like a moving star in the night sky. A few days before the comet reached our planet, you'd see it even during the day. You'd be able to distinguish its long tail, too. When the comet entered the atmosphere, it'd produce a booming sound so loud you'd hear it on the other side of Earth. At this point, the comet would begin to heat up because of friction with the air. It'd start burning. Countless pieces of debris would break away from the main body of the meteorite and fall to Earth. As soon as Bernardinelli Bernstein touched the surface of the planet, we'd see a flash so bright it'd outshine the sun. In a fraction of a second, a colossal amount of energy would be converted into heat. This would create the most powerful explosion in the history of our planet. It'd literally rip out chunks of ground and throw them into the air. The blast wave would incinerate everything within a few hundred miles. It continued to spread in different directions, breaking and bending trees. At one point, it reached snow-capped mountains and trigger huge avalanches that would cover many villages. The blast wave would go around the planet, shattering glass and buildings on all continents. Tsunami waves would be so high they would cover entire coastal cities. The most powerful earthquake in history would break the ground and create deep cracks. After the impact, billions of tons of dust and ash would rise into the air. A giant black cloud would completely block the sun's rays. Earth would be plunged into darkness. All the debris in the air would start melting. They'd turn into liquid lava and fall back to the surface, causing even more damage. The ash and dust in the air would cover the sun for several more months. During this time, the temperature on Earth would drop by several degrees. Even if they were hiding in deep shelters and bunkers, people, as well as all other living organisms on the planet, would be unlikely to survive this event. Fortunately, Bernardinelli Bernstein isn't going to approach Earth. Right now, the comet is about 20 astronomical units away from the Sun. That's 20 times the distance from Earth to the Sun. It means the comet will soon cross the orbit of Uranus. In 2031, it'll be 11 astronomical units away from our star. That's just outside Saturn's orbit. This is going to be the closest Bernardinelli Bernstein will approach the Sun. Then it will begin its flight back to the edge of the solar system. But the comet is bound to return again. It'll move away from the Sun and slow down until the star's gravity pulls it back. Then the comet will make another circle around our solar system. But that will take about 3 million years. Right now, we have other meteorites to worry about. For example, 3200 Phaethon. It crosses the orbits of Mars, Earth, Venus, and Mercury. Then it goes around the Sun and comes back. This cycle takes about 523 days. Then it starts over again. This meteorite is considered potentially hazardous because it crosses Earth's orbit at 7.5 Earth-Moon distances. During one of its last approaches to Earth, this 3.6-mile wide block of rock showered our planet with small meteors. Since the asteroid often passes by the Sun, its surface is most likely to look like the dry bottom of a mud swamp. It's covered in scales and cracks. As it flies past Earth, these scales break off and cause meteor showers. But the largest, potentially hazardous asteroid is the 1999 JM8. It's about the size of 77 soccer fields. It passes by Earth at 9 lunar distances. Its closest approach to our planet will happen in August 2137. If such a meteorite were to hit Earth, an entire continent could be wiped out. The rest of the world would experience massive tsunamis, but would survive the event. So naturally, scientists are thinking of ways to protect the planet from such a disaster. The first solution is a controlled Big Bang. One of the laws of physics says that if you apply some force in one direction, it'll cause a reaction in the opposite direction. So if we spot an asteroid that is about to collide with Earth, we'll need to send a rocket toward it. This way, we'll produce a controlled explosion, not inside, but right above its surface. The blast will be directed upward, and the asteroid will shift downward. Even this tiny shift would be enough to change the trajectory of the asteroid, and then it'll fly past Earth. Another way is to send a heavy object, like a spaceship, toward the space body. Every heavy object has its own gravity, so the spacecraft will have to fly close to the asteroid, which will attract the ship to its surface, but the engines of the spacecraft will resist. The ship will start pulling the asteroid in the opposite direction. This will change the trajectory of the asteroid, and our planet will remain intact. We can also ram the asteroid with the spaceship. Bam! Or we could build a space station, like the ISS. It would be equipped with a bunch of huge magnifying lenses. We would send the station closer to the Sun and start looking for potentially hazardous asteroids. Then, we'd point all the lenses so that the Sun's rays would focus on the giant rock. The heat would begin to vaporize the matter from the asteroid's surface. That's where physics would come into play again. The matter would evaporate upward, and the asteroid would move downward. We could also wrap the asteroid in a reflective film, something like foil. Usually, space bodies absorb most of the Sun's rays, but if the asteroid was covered in foil, the rays would bounce off its surface. This would create a weak pushing force. That should be enough to avoid the collision. Of course, we could attach rocket engines to the asteroid. This way, we would be able to not only change its trajectory, but also control it. But that would depend on the size of the asteroid and the number of engines. And then, we could use this massive rock to ram it into other, larger asteroids.
Can you imagine that all modern humans came from about 1,000 people? Around 800,000 to 900,000 years ago, almost all of our ancestors disappeared, leaving about 1% of the population behind. So, what the heck happened? The Earth often goes through glacial cycles, things that we call ice ages. Back in the past, they were pretty mild and happened regularly, about every 41,000 years. The ice ages happened because of the Earth's axis. Our planet is slightly tilted at an angle, which is why its axis isn't straight up. Over thousands of years, this tilt has changed a bit. This teeny tiny shift completely changes how much sunlight we receive, especially at the poles, and leads to incredibly strong cold or warm periods. About 2.6 million years ago, when early humans were settling in on Earth, the Pleistocene epoch started. That's the era we traditionally call the Ice Age, the one from the movies. Large ice sheets completely covered parts of North America, Europe, and Asia. It wasn't constant ice everywhere all the time. These glacial cycles came and went, and sometimes ice sheets melted for a while. But overall, things were still much snowier and colder compared to now. We can still see the evidence of this from back in the day. Those glaciers carved out valleys and left behind some awesome things like moraines and fjords. And since sea levels were super low, a huge part of the world was land. This allowed people and animals to travel between continents and spread everywhere. It was the time of the megafauna. You all know about it from the movies. Woolly mammoths, saber-toothed cats, giant ground sloths, and mastodons. Our ancestors had some fun times hunting all those giants. Now, humans didn't come from one lineage. It wasn't like monkeys slowly turned into humans. We also consisted of many species: Homo erectus, Neanderthals, and so on. But only one species, Homo sapiens, survived and turned into modern humans. Harsh conditions forced them to get smarter. They learned how to make tools, clothing, and shelters to survive. They became hunter-gatherers and invented fire, which turned out to be super useful during the Ice Age, you think? But they had no idea what horrible change was coming. Something disastrous happened about 800,000 to 900,000 years ago. Humans faced a drastic population crash. Only 1,280 people survived, give or take. Some 99% of early humans were wiped out, and this tiny 1% was lucky enough to become our ancestors. This almost extinction, unsurprisingly, was the climate's fault. It was the Middle Pleistocene transition. The Earth's orbit around the Sun changed its shape a bit. Carbon levels dropped. A lot of stuff was happening, and the Earth's climate was going wild, becoming incredibly cold and dry. The seas suddenly got chillier, and Africa and Eurasia experienced horrible droughts. Looking for food was almost impossible. Scientists learned this by taking the DNA of about 300,000 people from all around the world. They used a new method to help them map the history of human evolution over 1 million years and learn more about it. No wonder we can barely find any fossils from that time. There was almost no one around. What's interesting is that before that happened, most apes had 24 pairs of chromosomes. But because the population became so small, 2 sets got fused together, and we ended up with 23 pairs. This was the final straw that separated us from other apes. Chimpanzees, gorillas, and orangutans all have 24 pairs, but our fused one became known as the human chromosome. Like a ripple effect, this little thing influenced our brain side, helped us start walking on our toes, and even form language. It took humans about 100,000 years to recover from this catastrophe. Only after all that time, they started spreading around again. Isn't that insane how we managed to go from 1,000 to 8 billion people? In any case, the Ice Age finally ended about 11,700 years ago. The warm period, called the Holocene, began. As things got warmer, human civilizations finally began to develop. 5,000 years ago, it was ancient Egypt, then the Indus Valley Civilization, ancient China, and others. And while we've been thriving for a while, there's one catch. The Middle Pleistocene transition changed the length and intensity of glacial cycles. Before the transition, sure, there was the Ice Age, but the cold was milder, and the glacial cycles were shorter. Things got covered in ice sheets about every 41,000 years. But after the transition, the glacial periods became longer and more severe. These cycles started following a new pattern. Although they happened every 100,000 years, they were super intense. Ice sheets grew large, even extending to the south. So from now on, ice ages that will continue to happen in the future will be a bit different. The next one should be at least 50,000 years from now, maybe longer. It's good for us because it'll occur later. But at the same time, the consequences will be stronger. What our ancestors went through is called a population bottleneck. That's what we call a sudden and huge reduction in the size of a population. Usually it happens because of things like earthquakes, floods or droughts, fires, and even human actions. Just a few people survive, and only they can pass their genes to future generations. And we've got plenty of such bottlenecks in history. Our modern species, Homo sapiens, originally lived in Africa. Around 60 to 80,000 years ago, a small group of them left Africa and spread across the world. It wasn't on a whim though. They had to move somewhere because of the droughts and huge climate problems in Africa at that time. They had to go look for food and find new places to live. They traveled through the Middle East, moving into Europe and Asia, and eventually reaching Australasia and the Americas. They quickly settled across different continents and started mixing with local human-like species, like Denisovans and Neanderthals. But there was a problem. Originally, the African species were super genetically diverse, but since only a small part of them decided to move out, they carried just a bunch of these diverse genes with them. Unfortunately, this caused a bottleneck for everyone. Human-like species from other parts of the world became less genetically diverse. Since they had a smaller gene pool, they became more vulnerable to all the harmful stuff. The African population also had a drop in genetic diversity. But at least humans managed to survive. Although eventually, non-African populations really dropped, and there were no Neanderthals or Denisovans left, only us, Homo sapiens. That's why we can say that all modern humans came from Africa. Early humans sure had it rough. About 74,000 years ago, they went through yet another disaster, the Topo catastrophe. But keep in mind that all these things are just a hypothesis. It's not certain whether it actually happened. Now basically, scientists think that there might have been a supervolcanic eruption at Lake Toba in Sumatra, Indonesia. This volcano going crazy was an absolute catastrophe for Earth's climate and humans. The eruption was one of the most powerful volcanic events in the last 2 million years. It spewed out from 670 to 1,500 cubic miles of lava and volcanic stuff. Just so you know, there are about 3,100 cubic miles of water in our planet's entire atmosphere, and this eruption had almost half as much lava. This horrendous disaster led to the formation of Lake Toba, a massive caldera lake in Sumatra. It also spewed out tons of ash and sulfur dioxide into the atmosphere. This caused the so-called volcanic winter, which means that while it's not actually winter, the temperatures drop and the planet is freezing because all these ash clouds are blocking the sunlight from reaching the Earth. This event affected climate patterns for years to decades. This also most likely sped up the arrival of the next glacial cycle. Luckily, humans are crazy good at surviving. The global human population was reduced to a few thousand people yet again, and they still managed to overcome this.
Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plait thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? All right, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon, summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington Event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?
Whoa! A wall of fire spreads around the epicenter of the impact. It burns everything in its path. The waves raised by the explosion cover large cities, and earthquakes are so strong that giant skyscrapers fall like a house of cards. So, these are the possible consequences of the collision with the first interstellar object in history to visit our solar system. We discovered it in 2017, but we're still not sure what it is: an asteroid, a comet, or a spaceship of some outer space civilization. So far, scientists have named it Oumuamua. Sounds like a Hawaiian cow. Well, whatever it is, its speed is much faster than other asteroids, about 54 miles per second. At that speed, you could cross the US from coast to coast in less than 3 minutes. So this asteroid could travel from Earth to the Sun in about 2 months. By comparison, our rockets can travel up to 17,000 miles per hour. The same trip across the United States would take them about 9 minutes. So, many scientists speculate that this is an artificial object created by a very advanced civilization. Okay. The shape of the object supports this theory. It's long and narrow and resembles a spaceship. It's about half a mile long, way bigger than the Eiffel Tower. Scientists decided to see if Oumuamua was really someone's spaceship and pointed some radio telescopes at it. If the civilization on that ship had used communication or scanned us with their tech, we would have known about it. But there was complete silence. Kind of like that. Not a single radio wave. But that doesn't disprove the theory of outer space civilization. To find out for sure, we decided to determine the weight of the object. To do that, we use light. More precisely, its reflection. You see, different materials reflect light differently. We take an unknown black stone, for example. It absorbs almost all the light, reflecting almost nothing. Check out the catalog, it's charcoal. Knowing the size and material of the object, we can determine its weight. So, we need to see how much light this object reflects. And when scientists pointed their telescopes at Oumuamua, they learned that it reflects colors that match with iron and also with some solid rocks. And Oumuamua was flashing all the time, a bright flash. Then it would slowly fade, and then it would start to shine again. This means it was spinning. And it wasn't going around its axis like an arrow. It rotated chaotically, moving its edges up and down. Any artificial object or spacecraft would have been torn apart by such overloads. But Oumuamua is still intact. That means it's made of super hard materials that keep it from falling apart. And it's not hollow like a spaceship. It's one solid body. Hey, like me. The astounding speed of this object makes it pretty mysterious. Some comets can have the same or even higher speed, but they also have a kind of rocket effect. So when a spaceship starts from the launch pad, you see fire bursting out of its engines. Every second, the rocket mixes fuel with oxygen, ignites them, and ejects them at a tremendous speed. According to the laws of physics, this is like pushing off a wall. The rocket sort of jumps up from the combustion gases it throws down. That's how the rocket creates thrust and accelerates. Comets work on a similar principle. The sun's rays hit the surface of the comet. Light elements like ice start to evaporate. That gas goes one way, the comet goes the other. Just like a rocket, the comet is pushing off the evaporating gas and accelerates. This gas also forms the comet's long tail. It's as if the massive rock is dragging all this gas behind it. I can relate. Or it's like a car pulls air with it when it goes at high speed. But Oumuamua is not a comet, and it doesn't have that tail, and it doesn't have the same rocket effect as a comet. So it couldn't have accelerated to that speed. But some scientists believe that Oumuamua used to have a tail. Although we discovered it in 2017, it entered our solar system in 1995, and it was hit by the sun's rays even back then. When we discovered this asteroid, it had already lost about 95% of its mass. It simply evaporated. Other scientists believe that Oumuamua got this velocity during its birth, somewhere far away in another star system or nebula. Perhaps it was a dramatic collision of some exoplanet with another cosmic object. The colossal explosive energy of the collision threw the elongated shard into outer space. Or it could have been a supernova explosion. When a star reaches the end of its lifespan, it becomes a red giant. It's an inflated version of the star, hundreds of times bigger. Then it shrinks and explodes with tremendous force. The blast waves can travel many light years away from the epicenter, and it's one of the brightest events in the universe. So the supernova might have torn some exoplanet to pieces. One of them, Oumuamua, gained a lot of energy and speed and began its long journey toward Earth. This might explain why Oumuamua keeps spinning so wildly. But recently, scientists published a theory that Oumuamua may be a giant block of ice. The kind of ice we're used to is water, H2O, but Oumuamua could be nitrogen ice, N2. It may have remained intact in interstellar space for 500 million years. And when it arrived in our solar system, nitrogen ice could have reflected 2/3 of the sun's rays, so it didn't heat up as much. That explains why Oumuamua doesn't have a tail. You can find the same nitrogen ice on Pluto, as well as on Triton, one of Neptune's moons. So Oumuamua comes from a similar icy exoplanet. But we can find out for sure only by sending a space probe to it. Scientists came up with a plan for that called Project Lyra. The problem is that Oumuamua is leaving our solar system at tremendous speeds, much faster than our rockets can fly. And we need to catch up with this space rock as quickly as possible before it gets too far away. To do this, we can use a gravity maneuver. First, the space probe makes a flyby of Jupiter. It passes close to it to take advantage of its gravity to accelerate. After that, the probe will head towards the Sun, and it'll fly around it as close as possible to fire like a catapult towards the space rock. The second option for reaching the asteroid is to use microprobes. We have to launch about 1,000 of them into orbit. They should be no heavier than a match. Each of them will have a light sail the size of a boxing ring. Then we'll focus a powerful laser beam from the ground onto this sail. It will allow us to accelerate the probe to about 20% of the speed of light. It shouldn't go too fast not to fly past the asteroid. It should be able to enter its orbit or land on it. But if we're too slow, Oumuamua will leave our solar system before we can catch up with it. It'll be a great experience because in the future, we'll be able to use such asteroids as a space taxi. All we have to do is enter the orbit of such an interstellar asteroid or even land on it. Then we would keep moving through space at incredible speeds without using any fuel at all. This would be a great option for traveling long distances or to deliver supplies to other star systems. So why should we be afraid of such objects? Well, a collision with an asteroid the size of Oumuamua could wipe out an entire state. If it were to hit somewhere in the ocean, it could cause waves taller than our skyscrapers. Scientists are anxious to find ways to protect us against such objects. One of them is ramming. If we spot a potentially hazardous object, we could send a spaceship towards it, pedal to the metal. The spacecraft will have to ram the asteroid at an angle that will move its trajectory just a little bit. Moving it too much on a cosmic scale would only dramatically change the asteroid's final destination, and we only need to get the asteroid past our planet. We can also create a controlled explosion on the asteroid. It's based on the same principle. The force of the explosion would have to shift the trajectory of the asteroid slightly, or smash a giant rock into smaller pieces. Asteroids up to 80 feet wide would burn up completely in our atmosphere due to friction against the air. Rocks between 80 feet and half a mile in size may not burn up completely and cause local damage. Anything larger is considered very hazardous. You think? The traditional method of science fiction is to put rocket engines on the asteroid. Then we can not only change the trajectory of the space rock, but also control it. And we can use it against other asteroids. It would be something like space billiards. So, how do you feel about cooking? Nah, pasta and burgers are overrated. How about something more exotic, or rather, more cosmic? So, the recipe is simple. Take a team of enthusiastic astronomers and add some old images from the James Webb Space Telescope. Stir really well, and you'll get a shocking number of tiny asteroids in the asteroid belt between Mars and Jupiter. Yummy! The highlight of this dish is the direction in which some of the asteroids are moving, because in their way, there's our poor planet. Are we doomed just because you decided to cook? Now, the asteroids I'm talking about are much smaller than the massive space rock that wiped out the dinosaurs, but they can still cause considerable damage. They range in size from as small as a bus to as big as a stadium. But even those small ones pack quite a punch. Let's look at a recent dramatic example. It happened on February 15, 2013. A small asteroid just tens of feet wide exploded in an airburst over Chelyabinsk in Siberia, releasing an insane amount of energy. Many people witnessed and recorded the event, and it gave scientists vital clues. New computer models helped scientists reconstruct the size, speed, and impact of the Chelyabinsk meteor. It was likely an asteroid, about the size of a 5-story building, exploding from 15 to 18 miles above Earth's surface with an enormous, incomparable force. The blast shattered 1 million windows and hurt over 1,000 people. Fortunately, it wasn't powerful enough to cause too much damage, but it gave us an idea about how dangerous an airburst can be. Now, an airburst occurs when an object explodes high in the atmosphere, never striking the ground, but releasing enough energy to devastate the area. But back to the small asteroids. The most dangerous thing about them is that they hit the Earth far more often than the larger ones, about 10,000 times more frequently. To make matters worse, their small size makes them harder to detect in advance, leaving little time for preparation if one is heading towards Earth. Now, let's travel back in time. Uh-oh, dinosaurs, too far back. Ah, there we go. A team of astronomers is working on a special method to find small asteroids in telescope images that were originally taken to study distant stars. Using this method, they've looked through thousands of JWST images of a star system called TRAPPIST-1. It's located 40 light-years away and is one of the most studied systems outside our solar system. Now, while analyzing these images, they discovered 138 new asteroids in the main asteroid belt, plus 8 they already knew about. And guess what? Among the newly found asteroids, 6 seem to have been pushed into paths that could bring them closer to Earth. Who did it? Well, probably nearby planets. Are they holding a grudge against Earth? Interestingly, scientists thought they'd find just a few new asteroids, but the number was much higher than they expected. Yet, it's no wonder. Right now, they're exploring a part of space they didn't know much about before. Now, let's talk about the hero of the day, the James Webb Space Telescope. It's especially good at finding small asteroids because it can detect their heat. These asteroids give off infrared radiation, which is much easier to see than the faint sunlight that reflects off their surfaces. This technology allowed scientists to spot the smallest asteroids ever seen in the main asteroid belt. The asteroids they found are pieces left over from collisions between bigger space rocks. Finding them helps astronomers understand the history of the asteroid belt and improve methods for tracking small asteroids that could threaten Earth. The researchers are planning to use James Webb to observe other star systems for at least 500 hours. They expect this work to uncover thousands more small asteroids in the solar system. Other advanced telescopes, like the Vera C. Rubin Observatory in Chile, will also help. Starting in 2025, this observatory will use the world's largest digital camera to photograph the southern sky every night for at least 10 years. Each image will cover a huge area of the sky, about 40 times the size of the full moon. The observatory might find up to 2.5 million asteroids in just 6 months, almost doubling the number we know about. Recently, NASA has identified 2 small asteroids. They were supposed to pass near Earth on December 16, 2024. Luckily, neither posed any danger to our planet. The first asteroid was 71 feet wide, about the size of a large airplane, and was traveling at 10,800 miles per hour. The second asteroid was slightly smaller, 56 feet wide, but it traveled faster at 14,700 miles per hour. But hey, even though this time the danger is past, who knows what the future will bring? It may sound weird these days, but astronomers didn't really care much about small asteroids for a rather long time. They thought of them as just random space debris that got in the way of observing stars. Some even called them sky parasites. But now, the way we see these little space rocks has completely changed. You see, until recently, we could only spot really big asteroids, those over a mile wide. The smaller ones just blended into the background noise in telescope images. But then, a clever trick appeared where multiple images of the same part of the sky were combined, making those faint small objects finally stand out. The data from certain telescopes, along with the James Webb Space Telescope, helps us improve planetary defense. But there's more to it than just protecting our planet. Studying these small asteroids also teaches us about how the solar system evolved. There are so many of them because they're fragments from collisions between bigger space rocks. One researcher has said this is like looking at old data in a new way. These small asteroids, which people used to think of as space junk, are crucial for understanding our solar system and even preparing for whatever the future holds. Among those hundreds of millions of rocks orbiting the Sun in the asteroid belt between Mars and Jupiter, some are especially worrisome. They come close enough to Earth for it to be quite concerning. NASA classifies asteroids that orbit within 30 million miles of our planet as near-Earth objects, and those could pose a serious threat if they were to collide with our planet. Right now, NASA is closely monitoring an asteroid named Bennu. This is a fairly large space rock, measuring about 1,600 feet across. It could, potentially, crash into Earth in 159 years. First, the astronauts spotted it in 1999. So currently, experts believe that there's a small chance Bennu could drift into Earth's orbit and collide with our planet by September 24, 2182. Would it be bad? Well, to put it in perspective, Bennu is taller than the Empire State Building. If it hit Earth, it would generate 1,200 megatons of energy, an amount so massive that nothing on Earth could generate that. NASA scientists are particularly concerned about a tiny chance that Bennu could pass through a gravitational keyhole during a flyby in the 22nd century. This keyhole is a region in space that could set the asteroid on a path that brings it directly to Earth. Now, Bennu flies by Earth every 6 years and has had 3 close encounters with us in 1999, 2005, and 2011. Right now, scientists estimate that the chance of Bennu hitting Earth by 2182 is about 1 in 2,700, more than 5 times greater than the chance of being struck by lightning. Although the chances of Bennu colliding with Earth are very low right now, this space rock is still classified as a potentially hazardous asteroid because it might come as close as 4.65 million miles to Earth. Now, this asteroid is another space rock that we need to keep an eye on. It's a near-Earth object about 1,100 feet across, and it was discovered in 2004. Initially, it was considered one of the most dangerous asteroids ever detected. Apophis quickly gained attention because experts believed it could pose a serious threat to Earth because of its close approach to our planet in 2029. However, after further study of its orbit, astronomers determined that there was no risk of a collision for at least a century. Well, we can all breathe easier now, can't we?
Imagine an asteroid so full of valuable metals that it could make every person on Earth a billionaire. Well, that's not science fiction. It's 1/6 Psyche, a massive metallic space rock orbiting the Sun between Mars and Jupiter. It isn't just extraordinary because of its value, estimated at $10 quintillion. That's a figure that dwarfs the global economy many times over. It also has clues about the formation of planets, especially the rocky worlds like Earth. In October 2023, NASA launched the Psyche spacecraft. This mission is to explore the cosmic treasure trove. It's supposed to arrive at the asteroid in August 2029, and astronomers hope that it will give us some insights not just about the asteroid's glittering wealth, but also about how planets form and evolve in our solar system. But what exactly makes Psyche unique? First discovered in 1852 by an Italian astronomer, it was the 16th asteroid people identified, hence its name. It stands out among the millions of space rocks in the asteroid belt for one main reason: its metallic composition. While most asteroids are rocky or icy, Psyche seems to be made primarily of iron, nickel, and possibly even gold and other rare metals. At about 173 miles wide, it isn't the largest asteroid. It's easily dwarfed by others like Ceres. But its size is still impressive. After all, its surface area is 64,000 square miles, like that of the state of Florida. Astronomers think that between 30 and 60% of the asteroid's surface might consist of precious metals. They also think that this space rock might be the exposed core of a planetesimal. A planetesimal is basically a protoplanet, a large space body in orbit around a star, developing into a planet. And this planetesimal could have grown into a full-fledged planet if it hadn't been destroyed in some catastrophic collision billions of years ago. If this theory is correct, Psyche can give us a unique glimpse into what lies deep within terrestrial planets like Earth, where planetary cores are hidden thousands of miles beneath thick crusts and mantles. Now, remember that spacecraft that went to explore the asteroid? After embarking on its ambitious mission, the Psyche probe will travel a mind-boggling 2.2 billion miles to reach its goal. This journey will take nearly 6 years. On its way to the asteroid, the spacecraft will pass by Mars in May 2026 and use the red planet's gravity to slingshot itself deeper into space. This maneuver is called a gravity assist, and it will boost the velocity of the probe and refine its trajectory toward the asteroid. By the time it reaches its goal in August 2029, the spacecraft will be set to orbit the asteroid for at least 26 months. During this time, it will analyze its surface, figure out its composition, and attempt to unravel its history. The probe is equipped with some pretty cool tools. One of them is called a multispectral imager. This instrument will snap high-resolution images of the asteroid's surface. It's supposed to help astronomers to study its texture and composition. Then, the probe has a gamma-ray and neutron spectrometer. This instrument will measure the asteroid's chemical elements, including its metal content. A magnetometer will detect a magnetic field, if any, which could confirm Psyche's origin as a planetary core. And finally, an X-band radio system will help determine the asteroid's gravity field, which can offer insights into the asteroid's internal structure. NASA isn't sending the spacecraft to assess the value of the space rock as a mining target. Well, at least not yet. The main goal of the mission is science. Researchers hope to answer fundamental questions about how planets form and evolve. And this asteroid could help us understand what happens when molten material solidifies into a core. Another question we need to answer to is, why did it fail to become a planet? And understanding the history of the asteroid might shed light on why some celestial bodies grow into planets while others don't. While NASA's mission is purely exploratory, it has also sparked interest from the point of view of asteroid mining. With its estimated worth of $10 quintillion, Psyche could theoretically supply enough raw materials to revolutionize industries on Earth. Mining it is likely to be decades away, if it ever happens altogether, but the idea still sounds amazing. At the same time, if the asteroid's metals were somehow brought to Earth, their abundance could cause the value of precious metals like gold to plummet, and it would wreak havoc on global markets. Speaking of valuable resources, let's find out how Earth got its own gold, platinum, and other rare metals. These elements, aka highly siderophile elements, have a cosmic origin story, and it's every bit as dramatic as Psyche's. These precious metals were born in violent cosmic events billions of years ago. Many appeared in kilonovae, explosive collisions between neutron stars. These metals were then scattered across space and eventually became part of the gas and dust cloud that formed our solar system. When Earth formed, those metals sank towards its iron-rich core, but not all of them ended up deep inside the planet. Destructive collisions with rogue protoplanets like the Mars-sized Theia, which most likely helped to form the Moon, trapped some elements in Earth's mantle. Recent computer models have explained how this happened. After each major collision, Earth's surface temporarily became a magma ocean, a molten layer of rock. As metals sank through the magma, they reached a partially solid layer that slowed their descent, keeping them in the mantle instead of the core. These metals then moved closer to the surface under the influence of thermal convection. That's what made them accessible for mining billions of years later. While Psyche's metals are all over the news, space has more to offer than just gold and iron. Scientists have discovered, or rather theorized, the existence of different gemstones scattered across the cosmos, like diamonds. The thing is, diamonds are made of pure carbon, and this element is abundant in the universe. On Earth, diamonds form deep in the mantle under high pressure and temperature. In space, conditions for diamond formation can occur in surprising places. For example, nanodiamonds, which are really tiny diamonds, have been found in meteorites. Sometimes they contain gases that give us clues about the early solar system. Scientists believe that it might rain diamonds on our ice giants, Neptune and Uranus. There, high pressures compress carbon into crystalline form. Researchers have also predicted that exoplanets in other solar systems could have gemstones like rubies and sapphires, depending on their size and proximity to their stars. Even Earth's moon had its own share of cosmic minerals. Scientists have found some traces of cubic zirconia in lunar rocks. So space might hold even more treasures than we've imagined. But let's get back to the Psyche mission. It might not only reveal the whole potential of space resources, but also underline the issues we could face while dealing with them. For example, mining an asteroid would require the usage of autonomous robots, machines capable of operating in harsh space environments. Plus, we would need efficient transport systems to bring materials back to Earth or process them in orbit. We would need to make sure that mining activities wouldn't damage ecosystems or space environments. There are also legal and ethical issues, like the Outer Space Treaty of 1967. It prohibits any nation from claiming sovereignty over celestial bodies. But with private companies entering the space race, debates over ownership and resource sharing are heating up. And finally, bringing such amounts of metals to Earth could destabilize global markets. So, experts suggest that space resources might be better used in space, for building habitats, satellites, and spacecraft. But no matter whether we ever mine 16 Psyche or not, its exploration will teach us more about the early solar system and the processes that shaped our planet. As of December 1st, 2024, the probe is heading for the asteroid, following the orbit around the Sun. Its journey promises not only to deepen our knowledge of the universe, but also to redefine what's possible for humanity as we reach for the stars.
Asteroids are a serious, very real danger. Some of them are big enough to cause a lot of trouble if they collide with Earth. One asteroid in particular is making headlines these days. A new study has revealed there's a small chance it could hit our planet during its close flyby in 2029. But the question is unusual. Will the asteroid survive this encounter? Apophis, which got its name from Apep, the Egyptian deity of chaos and disorder, has become one of the most infamous asteroids. Discovered in 2004, this space object is about 1,100 feet wide. It's about the height of the Eiffel Tower in Paris. Because of its size and the close flyby predicted for 2029, astronomers classify Apophis as a potentially hazardous object. Those are asteroids and other space objects that pass close to Earth and are big enough that we really need to pay attention to them. Right now, scientists say the chances of a collision are slim, less than 1 in a billion. So, at the moment, we can probably claim that Earth is out of danger. But the same can't be said about the asteroid itself. When Apophis passes close to Earth in 2029, our planet's gravity is likely to shake it so violently that it may experience something like an earthquake, a cosmic asteroid quake, if you will. The stress from this gravitational force will probably cause parts of the asteroid's surface to crack off and fly into space. And even though this might not be a full-blown disaster, and the asteroid won't fall apart completely, it's very likely to lose some material during the flyby. Some of this debris might just stick around in orbit, while other bits could fly off into deep space. Over time, this catastrophe could affect Apophis's rotation, causing it to spin differently or tilt in a way it hasn't before. And this is a phenomenon scientists are really interested in, because it could teach us a lot about how asteroids react when powerful gravity is pulling on them. Now, let's get back to Earth. Well, we haven't left. Anyway, even though the asteroid isn't big enough to wipe out the planet like the asteroid that destroyed the dinosaurs, it's large enough to cause serious damage to a large city if it ever collided with Earth. It could mess with the climate all over the planet, too. At the moment, it looks like the space rock will sail past Earth at a distance of around 20,000 miles. It's still worryingly close, but far enough to avoid a collision. To put it in perspective, that's less than a tenth of the distance between Earth and the Moon. So while Apophis likely won't hit us, this flyby could still cause problems for some of the satellites orbiting Earth. They will be much closer to Apophis than we are. The key point is that we can't rule out a risk of a collision in a few more years. As Apophis gets closer, astronomers will keep a very close eye on its trajectory to make sure it doesn't veer off course due to the influence of Earth's gravity. In fact, this gravitational pull could actually cause some serious changes to the asteroid itself. Now, even though Apophis is not likely to cause a global disaster if it were to hit Earth, the consequences would still be pretty severe. The impact could destroy an entire city, and the resulting climate changes could mess with food production for years. It wouldn't be an extinction-level event, but it would still be a huge deal. Now, Apophis is not the only asteroid we need to worry about. Scientists are constantly on the lookout for other asteroids that could potentially cause harm to our planet. Thanks to new technology, astronomers can now track dangerous space rocks from way farther out in space. One cool new method they're using involves studying meteor showers. These showers are actually caused by long-period comets that have been orbiting the Sun for hundreds or even thousands of years. As these comets pass by, they leave a trail of dust and debris, which can end up creating meteor showers when Earth passes through them. Scientists analyze the properties of meteor showers, like their speed, direction, and where they come from. This can help them trace the particles back to their parent comet or asteroid. It's actually a big deal, because it means we might be able to spot potentially hazardous asteroids long before they get close to Earth. The upcoming Legacy Survey of Space and Time project, which is being run out of the Vera Rubin Observatory in Chile, is going to help astronomers track these space rocks from even farther away. Astronomers are going to create a detailed map of the sky and the regions where meteor showers are most likely to occur. It'll help them predict which asteroids might become a problem for Earth in the future, giving us plenty of time to prepare or come up with a plan. But even now, there are many space rocks that can potentially cause a lot of trouble to our planet. Let's look at some of them. Here's the asteroid Bennu. Astronomers discovered it in 1999. This carbon-rich rock is about 1,600 feet across. It's the height of the Shanghai World Financial Center. Didn't you know that? At the moment, this asteroid is the greatest threat to Earth that we're aware of. But don't panic yet. The collision won't happen for a long time. In fact, scientists calculate a 0.037% chance, which is about 1 in 2,700, of Bennu striking Earth on September 24, 2182. I won't be around then. If Bennu does hit our planet, the impact would release so much energy that it would be enough to cause massive destruction in a large region. But luckily, it wouldn't wipe out the entire planet. Still, if Bennu hit a city, the consequences could be catastrophic. NASA's OSIRIS-REx spacecraft has recently visited Bennu and returned with samples, so scientists are learning more about this asteroid all the time. The next asteroid is another one to keep an eye on. It was first discovered in 1950, but wasn't seen again until 2000. Right now, scientists say there's a very slim chance, 1 in 34,500, that it could hit Earth on March 16, 2880, 800 years into the future. So, am I worried? Nah. If it did strike, it would release so much energy it could lead to a global catastrophe, potentially wiping out humanity. Or not. Our next asteroid has been discovered only recently. It was spotted in October 2023. It has a very low chance of striking Earth on October 10, 2119. Man, they got it down to the day? Now, if it were to collide with our planet, the impact would release a lot of energy, which would have a devastating effect for large areas. So, while the arrival of this asteroid is a long shot, this asteroid is still worth keeping an eye on. Now, this asteroid is known as a lost asteroid because it hasn't been seen since 2007. No wonder, it has a very uncertain orbit, and we can't predict its movements. NASA says there's a tiny chance, about 1 in 10 million, that it could strike Earth on March 3, 2030. If it did, the energy released would be able to cause huge regional damage. Finally, we've got this space wanderer. On the one hand, it hasn't been seen since 1979. On the other, scientists believe that there's a very low chance that it could hit Earth on December 14, 2113. Mark your calendars. If it did, the impact would cause a lot of damage and devastation, but it would not lead to the end of humanity. Now, in any case, even though the chances of an asteroid hitting Earth are low, the consequences of such an event could be huge. That's why scientists are so focused on studying these space rocks and tracking their movements. Thanks to new technologies, we can track dangerous objects from farther away and catch them earlier. It can give us more time to react and come up with some effective solutions. Look up. The sky is dark, seemingly lifeless. But then, you notice something that wasn't there before. A bizarre, almost invisible light illuminates the previously black space. It's too late to run. You're both lucky and unlucky at the same time. You're witnessing the awakening of a giant, previously dormant black hole. Is it going to swallow both you and our world? Supermassive black holes, huge space objects millions of times heavier than our Sun, live in the middle of most galaxies. But they're really hard to see or study. Most of the time they sit quietly and don't do much for a long time. That's what was happening with a giant black hole in a faraway galaxy. This galaxy is 300 million light-years away from us, in a part of the sky called Virgo. For many years, the black hole there wasn't doing anything exciting. It was quiet and resting. But in late 2019, something strange happened. The galaxy suddenly got much brighter. It started flashing a powerful X-ray light. It was something scientists hadn't seen there before. This surprised astronomers, so they started watching it closely. After a few years of studying it, scientists have concluded that the black hole has likely woken up from its quiet state and become active. Now, the middle of the galaxy is really bright. It might mean the black hole is pulling in material and producing lots of energy. Astronomers even gave this black hole a fun nickname, Ansky. And the coolest thing about all this is that it's the first time we're watching a supermassive black hole switching to an active state in real time. Scientists at the European Southern Observatory in Germany were the first to notice something strange. They used special space telescopes, like NASA's Swift and another one called eROSITA, to look for X-rays coming from Ansky. At first, they didn't see any. Then, in February 2024, another group of scientists noticed something new – bursts of X-ray light coming from Ansky. And these bursts weren't random. They happened almost like clockwork, at nearly regular times. This kind of flashing has a complicated name, quasi-periodic eruption, or QPE if you want to make it short. It's when a black hole suddenly flares up with a burst of energy, but only for a short time. And this is the first time anyone has seen a QPE in a black hole that was waking up after being quiet for so long. These kinds of events are also super rare. Scientists only found the first QPE in 2019, and they've only seen a few more since then. No one knows exactly why they happen, but watching Ansky might help scientists learn more about how black holes behave and grow. One important tool they used was the XMM Newton Space Telescope. It's the only one that can see the very faint background light between the flashes. By measuring how dim Ansky gets between bursts, scientists could figure out how much energy the black hole sends out during each flare. You might know that black holes have super strong gravity that pulls in anything that gets too close, even stars. If a star gets caught, it can be stretched and torn apart. The pieces of the star form a super-hot glowing ring that spins around the black hole. This ring is called an accretion disk. Scientists think that the quick flashes of X-rays, QPEs, might happen when something, like a star or even another small black hole, interacts with this spinning disk. QPEs have sometimes been linked to stars being destroyed. But with Ansky, there's no sign that it destroyed a star. So scientists started thinking of other reasons. Maybe the disk around Ansky is made from gas that the black hole grabbed from nearby space, not from a torn-up star. And maybe something small, like a planet or a star, is passing through this disk over and over again, shaking it up and making it flare with bright X-ray light each time. What makes Ansky really special is how big and powerful its bursts are. According to a student at MIT who worked on the study, Ansky's X-ray bursts last 10 times longer and are 10 times brighter than normal QPEs. Each burst gives off 100 times more energy than other ones scientists have seen. And the timing is strange too. Ansky has a pattern of flashing about every 4.5 days. It's the longest wait time between flashes ever seen. These strange features are making scientists rethink how QPEs happen and what causes them. Sadly, we don't have enough data yet to know for sure. Astronomers need to watch more of these events to figure it out. Now, you might be wondering how scientists even find black holes. After all, they capture everything, even light. Indeed, these space monsters are really hard to see. They're basically invisible. But scientists pay attention to what's happening around them. It can be glowing gas and dust somewhere in space. The thing is, black holes often have a spinning ring of gas and dust around them, called an accretion disk. This ring gets super hot and shines in X-rays and other kinds of light, which telescopes can spot. It can also be moving stars. Big black holes, like the one in the middle of our Milky Way galaxy, have such strong gravity that they make stars orbit around them. Scientists watch these stars move in special patterns and prove that there's a giant black hole hiding there. This discovery won a Nobel Prize in 2020. They're also on the lookout for ripples in space, because when giant objects like black holes move or crash into each other, they send out gravitational waves. Scientists have built special tools to feel these ripples and learn more about black holes. And finally, it's bending light. Black holes have so much gravity they can bend light from stars behind them, like a cosmic magnifying glass. This trick, called gravitational lensing, can help scientists find black holes that are hiding all by themselves. Now, you should keep in mind that, unlike some stereotypes, black holes are not wormholes, magic tunnels that take you to other places in space or different universes. Once you get into one, there's no way out or to the other side. Neither are black holes some kind of space vacuum cleaners. They don't go around swallowing everything they come close to. If you're far away, their gravity is just like that of any other object with the same mass. The black hole that's closest to us on Earth is called Gaia BH1. It's about 1,500 light-years away. As for the farthest black hole we know about, it's located in the middle of a faraway galaxy 13 billion light-years away. The largest black hole we've seen is called TON 618. It's 66 billion times heavier than the Sun. And the smallest black hole is just 3.8 times heavier than the Sun and sits next to a star. By the way, all black holes spin or turn really fast. The fastest one spins over 1,000 times every second. Plus, big black holes in the middle of galaxies can shoot out particles at super high speeds, almost as fast as light. If something falls into a black hole, spaghettification occurs. This object gets stretched out in space like a noodle because of the black hole's immensely strong gravity. And speaking of gravity, if our Sun were replaced with a black hole that had the same mass, Earth and the other planets would still orbit it in the same way. The gravity wouldn't change just because it's a black hole. Scientists have discovered two main kinds of black holes. The first are called stellar mass black holes, and they're usually about 5 to maybe 50 times heavier than our Sun. The second type is supermassive black holes, which are incredibly huge. Some of them 100,000 times to even billions of times heavier than the Sun. There might also be middle-sized black holes, kind of like the in-between type, but no one has found one for sure yet. Stellar mass black holes can form when two neutron stars smash into each other. Also, two smaller black holes can join together and make a bigger one. That's one way black holes grow. But supermassive black holes are still a big mystery. Scientists aren't exactly sure how the universe creates black holes that large.
Right now, 4 tiny, Earth-like planets are chilling around one of the closest star systems to us. We're talking second closest. These little rocky worlds are each about 20 to 30% the mass of Earth. So not quite Earth 2.0, but still pretty solid. Will one of them become our new home one day? Well, all of them are pretty close, so future humans might actually visit them someday. Not like next year or anything, but we could potentially send missions there. Don't expect any extraterrestrial neighbors, though. Those planets probably aren't home to life, or at least not anything we'd recognize. Let's take a look at them. The planets are called Bernard B, C, D, and E. How creative, huh? The innermost has a mass of 26% of Earth. The second one is a bit bigger, with a mass of 30% of Earth. The third one has 4% more mass than the previous. And the outermost is… no, it's not the biggest. Actually, it's just a baby, with a mass of 19% of Earth. All the planets are likely rocky, like the inner planets of our solar system. They orbit their star very closely. That's why they only need a few days, under a week, to make a full circle. Now, what about that star these little guys are circling? It's called Bernard's star. Astronomers have always had a hunch there might be at least one planet orbiting it. First off, this star is super close, in cosmic terms of course. Only the Alpha Centauri trio is closer to us. Bernard's star is just under 6 light-years away, which is basically next door. At the same time, it's not like our Sun. Bernard's star is a red dwarf, the most common kind of star out there. It's got only about 1/6 the mass of the Sun. But red dwarfs are a goldmine for learning about planets outside our solar system. And studying Bernard's star can help scientists figure out what planets around single stars, like our Sun or this red dwarf, are like. Or what kind of environments red dwarf planets might have. And most importantly, we might finally find the answer to this super important question. Could any of these places actually support life? For the longest time, scientists thought there might be a big Jupiter-like gas giant hanging out near Bernard's star. All because the star has a little wobble. It looks as if it shifts towards and away from Earth over time, so something might be tugging on it. Interestingly, it wasn't a giant planet doing the pulling. According to a study from March 2025, it's actually 4 smaller rocky planets, each about 4 times the mass of Mercury. One day, they ganged up and started tugging on the star together. These planets are incredibly close to their star, so close that they can whip around it in just a few days. Sadly, because of that, they might be way too hot for anything like life. Besides, since these four seem to explain all the star's movement, the researchers think there's probably nothing else orbiting the habitable zone. So, there's no Earth 2.0 orbiting around Bernard's star. Still, it's an awesome find, especially since this star is basically our cosmic neighbor. Plus, the system might not stay off limits forever. With nuclear fusion engines or light sails, futuristic propulsion systems that could make the trip way faster. We might probably go there one day. And then we'll finally figure out if these worlds are really lifeless and maybe even colonize them. Now, let's see how scientists found the star's hidden planets. Normally, astronomers spot exoplanets when they catch them crossing in front of their stars and blocking some light. But Bernard's star is tricky because, in our view, it's like we're looking from above the system, so its planets don't block the light in the usual way. That's why they call it the Great White Whale of planet hunting. To get around this, researchers used a super sensitive instrument called Maroon X attached to the Gemini North telescope on Hawaii's Mauna Kea volcano. Over 112 nights, spread out across 3 years, the telescope picked up tiny changes in the star's movement. These shifts let scientists figure out how many planets must be tugging on the star, as well as estimate their sizes. At first, they found 3 planets. But then they used another device, deliciously called Espresso, and located at the Very Large Telescope in Chile. And only after a shot of this espresso did they find a 4th planet. By combining the data from both instruments, they were able to more or less confidently say their findings were solid, not just random glitches in the data. Even though red dwarfs, like Bernard's star, are the most common type of star in the universe, most are way too far for us to see planets around them easily. These new findings suggest that small rocky planets could be pretty common around these stars, and that's huge for future discoveries. Now, finding new exoplanets is cool and all, but it might be even more exciting to dwell on their birth and evolution. And a recent study has made the sweetest discovery ever. Newly born exoplanets might actually look like Smarties, that popular British candy, rather than spheres. We've always kinda assumed that baby planets are born ball-shaped, but they might be oblate spheroids instead. A team of scientists from the University of Central Lancashire in England used computer simulations to build a model of the formation of planets in dense gas disks surrounding young stars. After that, they compared these models with actual observations and noticed that the young planets took pretty unusual shapes. The thing is that even though almost 6,000 exoplanets have been discovered so far, astronomers still don't have a clear understanding of the sequence of events marking their birth and early evolution. But this new research might finally shed light on this process. So, the astronomers examined the formation mechanisms of gas giant planets like Jupiter and came to the conclusion that planets built up from their centers. After that, the researchers focused on the initial shapes of such planets. They were also interested in how they could encourage the growth of these planetary seeds. How could they turn into such massive planets, some of them bigger than our solar system's largest giants? According to the standard theory of the formation of planets, such growth happens gradually and smoothly. First, dust particles start to stick together, turning into larger and larger objects. This process lasts for a very long time and is known as core accretion. It's the model of planet formation scientists favor. There's another theory, according to which planets' birth might happen over shorter periods of time. This data involves a protoplanetary disk, a disk of gas which makes up 99% of its mass, and dust, around 1%. This disk orbits a newly formed star, and hypothetically, planets might form from this cloud. Protoplanetary disks are likely to be common byproducts of star formation. They might range in mass from 0.001 to 0.3 solar masses. Inside such disks, matter slowly moves inward, and dust particles grow bigger, to the size of pebbles. At one point, after 2 to 3 million years, a giant rotating protoplanetary disk breaks into pieces, and that's how baby planets are born. This theory is known as the disk instability model. As for the model built by the team, it seems to support this second, less favored theory: rapid planet formation through disk instability. All because this theory explains how large planets can form relatively quickly at pretty large distances from their host stars. As for the weird flattened shape of these newly formed planets, it might be due to the material falling onto them. Most likely, it goes mainly to the poles of new planets. One of the main conclusions of the research is that the appearance of young exoplanets, as we see them from Earth, may vary depending on how they're angled. If Earth is directed face-on to an exoplanet, it will seem that the latter has a traditional spherical shape. But if seen on edge, a baby exoplanet will look like a real smarty. The team is going to continue to investigate the formation of planets with the help of an improved computer model. They believe they can find out the role the environment around a young planet plays in affecting its shape and formation.
Pretty soon, you'll be able to charge your phone in your pocket while walking around the house. And meanwhile, your electric car will refuel while just standing in your driveway. Power will run to all your gadgets through the air without any wires whatsoever. I know it sounds a bit sci-fi, but scientists have figured out how to do it. Don't worry, they're not going to zap electricity through the air like lightning. Instead, they'll use something much safer: magnetic fields. Let's say you have a special coil of wire that makes a magnetic field when it gets power. If you bring another coil close to it, that second coil absorbs the energy and turns it into electricity. That means you can power things without plugging them in, like a light bulb that turns on all by itself. And according to scientists at the World Health Organization, these magnetic fields are completely safe. Now, I suspect you've already used an early version of wireless electricity. When you place your electric toothbrush on its charger or the phone on the charging mat, electric energy jumps between them. There's a special coil inside the charger that creates an invisible spinning energy field when it gets electricity from the wall. The toothbrush or phone has another coil inside it that catches this energy and turns it back into electricity to charge the battery. This is called electromagnetic induction, but this method only works for short distances and wouldn't be useful for powering your entire house. Some companies are already working to make this technology perfect and accessible. One company has invented their method to send power through the air called air cord. They use it in real-life products. One cool example is tiny video screens placed next to products in supermarkets with changing images. These screens don't need batteries or power cords. Another gadget that's running on this tech is a smart lock designed by the same company. Normally, smart electronic locks need powerful batteries, but this one stays powered without a battery and gets energy from a wide-charge transmitter in the ceiling. That transmitter is like an invisible power outlet. It works similarly to a TV remote, where you use an infrared beam to control the gadget from a distance. In this case, the transmitter takes electricity and sends it to all gadgets that need power as an infrared beam. The transmitter analyzes each device to see how much power it needs, just like a Wi-Fi router manages the internet for different devices. If no devices need power, the transmitter goes to sleep, but it wakes up now and then to check if anything needs charging. Nikola Tesla, a brilliant inventor and electrical engineer who made significant contributions to the development of electricity, would be really happy to see all this come true. He believed he could build a system that would transmit electricity and communication signals through the Earth's ionosphere all over the world. To prove his idea, he built a special Wardenclyffe Tower in New York. His plan was to use the Earth itself like a giant electrical circuit. In 1899, Tesla traveled to Colorado Springs, known for its big thunderstorms. He built a lab there to test his wireless electricity ideas. The high altitude and frequent lightning storms made it the perfect place for his experiments. Then he returned to New York, and with money from a wealthy investor, he started building the Wardenclyffe Tower. Tesla placed iron rods and copper plates under the tower to help send power through the Earth. There would be a huge metal dome on top of the tower. By 1902, the tower and lab were mostly built, but Tesla ran into funding problems. The Wardenclyffe Tower never worked as Tesla had hoped, and in 1917, it was torn down and sold for scrap. In any case, Tesla's idea only worked for short distances. The farther the electricity had to travel, the weaker it became. Scientists needed a way to send energy over long distances, and they found two viable solutions in the middle of the 20th century: microwaves and lasers. In 1964, engineer William C. Brown flew a tiny helicopter for 10 hours using only microwave power. Then, in 1975, Brown and a NASA scientist, Richard Dickinson, sent 30,000 watts of power over a mile using a research station called Venus. But there was still a problem. Half of the power was lost before it reached its destination. Over the years, technology kept improving. Computers, lasers, solar panels, and transistors became more advanced and opened new horizons for wireless electricity. It could eventually help us switch to cleaner energy from fossil fuels like coal and gas. New Zealand-based company Emerald uses power beaming technology that starts with electricity from the power grid and turns it into microwaves. These microwaves travel through the air from a sending antenna to a receiving antenna, which turns them back into electricity that we can use. But there's a problem. Various kinds of waves work in different ways. Microwaves can travel long distances without losing much power, which makes them great for sending energy to remote islands or factories. But if you try to send microwaves all the way from space, you need a receiver the size of a city. Lasers can make the energy beam smaller and more focused, which means the receiver can also be tiny. But lasers can be blocked by things like clouds, fog, or dust. Right now, power beaming won't replace power lines over huge distances, but it could be used for smaller projects like charging flying taxis and delivery drones in the sky, powering robots in cities and factories, and replacing backup generators during emergencies. Countries all over the world are investing in power beaming. Europe is focused on clean energy. The Japanese Space Agency hopes to have a giant solar power station orbiting Earth, collecting sunlight and beaming electricity down to us by the 2030s. This space station could send 1 gigawatt of energy, as much as a big nuclear power plant produces in a year. The space power station is still a work in progress, but the technology is getting better and cheaper. So, in the future, we might have a world where there are no more tangled wires, no more ugly power lines, and even free electricity for everyone. Japanese scientists are now working on another groundbreaking tech, a special machine that can turn sunlight and water into hydrogen fuel. This clean energy source could one day power cars, homes, and even entire cities. The current reactor is as big as a small house. It works by using photocatalytic sheets, which act like tiny solar panels that absorb sunlight and trigger a chemical reaction. This process splits water molecules into oxygen and hydrogen. It allows the hydrogen to be collected and used as fuel. Right now, the process isn't efficient enough to produce hydrogen on a large scale. Most existing methods of making hydrogen still rely on fossil fuels. But the scientists behind this new reactor found a better way. Instead of breaking water apart all at once, which wastes energy, their machine does it in 2 steps. First, it separates oxygen, then it collects hydrogen to make the process smoother and more effective. The team used a special photocatalyst that responds to UV light, and they found that under natural sunlight, the solar energy conversion efficiency was 1.5 times higher than in the lab. In some places with stronger sunlight, the efficiency could be even greater. But still, at its current stage, the reactor only reaches about 1% efficiency, which is far too low for commercial use. Scientists believe that for this technology to become practical, they need to increase efficiency to at least 5%. To make this happen, they need better photocatalysts and larger reactors, and they would also need to find safe ways to handle a tricky byproduct, which is a highly flammable gas created during the process. But if they can boost efficiency, many scientists and companies will start mass-producing this technology, leading to clean, renewable hydrogen energy on a large scale.